Okay, folks, we got a couple more days of radicals. Today is going to be mostly a review, and then we have a new topic we're going to do next week on radicals. But we're going to kind of tie everything together that we've been doing. There's going to be something, a little bit of new stuff, but not much. These first four problems are all review. So I would like for you to, try to do these first. Now remember, I am going to do a live lesson on Wednesday, April 8th at 1:30. Talk through all this stuff and have some back and forth dialogue. So if you need some help or you're struggling, please join that lesson. Make sure you have authenticated Nutria Zoom account. Okay, so that's Wednesday at 1:30. All right, so try these first. Now I'll quickly talk through them. Simplify the 24, break it up to 4 and 6. That 4, square root of 4 comes out as a 2, turns that 3 into a 6. Now we have like terms. 6 root 6 minus 2 root 6 is 4 root 6. No work to show here. You just go straight to the answer for number 2. You have like terms. You can combine root 3's. You get 10 root 3. Number 3, you don't have like terms, but you can simplify the 27. Break it up to 9 times 3. This comes out as 3 root 3. Now remember, don't make that mistake. There's an invisible 1 here. So when you combine these, you end up with 4 root 3. We've been doing that for a few days now, those 3 problems. Number 4, this is something that we did new on Monday. I'm going to distribute. Root 2 times root 2 would be root 4. Root 2 times root 3 would be root 6. But remember, this becomes 2. This here stays as root 6. There are no perfect squares that you can take out of that. So we're all done with that one. Okay, now number 5, this is some new stuff, so you're really going to be paying attention here. It's new in that we haven't done stuff exactly like this, but we've done a lot of problems that have similar components to it. I'm hoping that you're thinking about distribution, and that's what we're going to do. You don't have to draw these arrows. I'm just doing it to show you. I mean, we've been distributing before. Root 2 times root 2 is root 4. Root 2 times negative 1 is just negative 1 root 2. Done with that. Slide over to this 1. 1 times root 2 is positive root 2. Positive 1 times negative 1 is just negative 1. Okay. Now check this out. This is kind of cool. In the middle, we have like terms. We have negative root 2 and positive root 2. They can be combined, and actually in this case, they just cancel out, right? Because you have one's a negative, one's a positive. Square root of 4 becomes 2. You got this minus 1, so our final answer is just 1. Here's one, same thing. If you want to try to do it yourself, you can pause it and give it a shot. I'm going to talk through it right now, though. Again, we're still distributing. 3 root 2 now. So 3 root 2 times 2 root 5. The numbers in front, those are like type numbers. So that's 3 times 2 is 6. Root 2 times root 5 is root 10. And now we do this times this. So 3 times 4 is 12. And then you get root 4. We're done with the 3 root 2. Now we slide over to this root 5. Multiply it here. Remember, there's an invisible 1 in front. Negative 1 times 2 is negative 2. And then you get root 25. And then lastly, remember the negative 1's there. You get negative 4 root, what's that? Root 10. So now, if you guys notice here on the ends, we have like terms. 6 root 10 minus 4 root 10 is 2 root 10. Here in the middle, this root 4 comes out as a 2, turns that 12 into 24. Root 25 comes out as a 5, turns that into negative 10. Now we have like terms there. So we end up with 2 root 10 plus 14. Can't combine those because they're not like terms. Let me just check something here. Okay, I thought I had changed that, but maybe not. All right. So down here, you see this squared? That is the same thing as multiplied by itself, right? So, and now it's just a distribution problem, just like you did in the first two, in the number 5 and number 6. 2 root 3. So now we distribute. 2 times 2 is 4 root 9. And then you get, remember, there's an invisible 1 in front of this. So you get 2 root 15. Slide over this. Invisible 1 times 2, you get 2 root 15 again. And then root 5 times root 5 is root 25. Notice how we have like terms here in the middle. Let me first, this comes out as 3, turns it into 12. I'm going to combine these like terms. This comes out as 5, and now we have like terms here on the end that can be combined, and I get a final answer of that. This thing was supposed to be in the front. It's probably on the front on your sheet. It's just distribution. It's just written backwards. It's still the same thing though. Remember, there's an invisible 1 here, so 2 times 1 is 2. Then you get root 9. And now you do 1 times root 3, which is just root 3. This comes out as a 3, turns that 2 into a 6. So now we just have 6 plus root 3. Again, pause this at any time. Okay, this is older stuff now. You should be able to do both 9 and 10. You should stop and give this a try right now. Okay, I'm going to combine these by multiplying. 2 times 5 is 10. Root 3 times root 6 is root 18. I can break up the 18. Square root of 9 is 3. Turns that 10 into 30. And we're done. Square root of 9 is a perfect square. Take that out. I got an even power. Cut that in half and take that out. Now inside we have the odd power. We're going to reduce it by 1. And now y to the 4th comes out as y squared. What's left inside? Root y. Okay, next page. These are actually pretty simple. Look, what do you notice at the top for number 11? 49 is I'm hoping that you're saying perfect square. What's 25? It's a perfect square. What's x squared? It's a perfect square. So square root of 49 is just 7. You're done. Remember, the even power comes out and you cut the power in half. You got a perfect square downstairs. You're done. So some of these are kind of easy. This was written a little bit differently on your worksheet. I want you to realize that these are the same thing. When you have the root over the whole thing, it's It's the same thing there, okay? So now we can multiply, we have to rationalize. We don't want this in the bottom. This is what we were doing on Monday. So we're going to multiply by root 8 over root 8. So on the top, we get 2 root 24, because invisible 1. Remember, root 8 times root 8 is plane 8. And 2 over 8 reduces to 1 over 4, but I don't write the 1. I can break up the 24 to 4 times 6. The 4 comes out as 2. And 2 over 4 can be reduced to 1/2, but you don't write that as either. This one you should try on your own. Pause it. Break the 50 up to 25 times 2. Change the odd power, reduce it by 1. 25 comes out as 5. Y squared comes out as y. And that's left inside. All right, we got 2 more problems. These problems here shouldn't be there. So square means times by itself. We haven't seen anything like this, but the idea is not new. 7 times 7 is 49. Root 5 times root 5 is root 25. That comes out as 5. Multiply 5 times 49 and you get 245. My suggestion would be here is to combine these. Everything's in the root, so you can multiply it. And remember, you add the exponents. Break up the 80 to 16 times 5. Change the a to the 5th to a to the 4th times a. That comes out as 4. This comes out as a squared. And you have 5a left inside. Now again, kids, I know I went a little bit fast there, but there's a couple reasons for that. One is you can stop this as often as you want and replay this as many times as you need to. Also, the other reason is, remember, we are doing a live lesson on Wednesday, April 8th. The lesson starts at 1:30. The Zoom session will actually start at 1 o'clock, but the first half hour is just for office hours if you have questions. If you don't have any questions on your homework or whatever else, you can just show up for the lesson at 1:30. Okay? Hope to see you guys then.